Now, this one, we are this one in this study we focus more on the solid product, solid product. Solid product. We focus on the solid product, which is the biochar. In that study, we use the wet purification process, which is the mild hydrothermal process or wet hydrothermal process. For this conversion, because in this study we are using a few types of the waste materials. The main materials we are using is the microalgae, because normally the microalgae are in the wet form, so we don't want to have the dry process. So that's why we think of this process whether it's suitable or not, or feasible or not. What we do on that this study. Yesterday I think I briefly explained already. The pharmaceutical companies they culture the algae, then they extract the protein content or some pharmaceutical compound that useful for the applications. And after that, the leftover biomass, so we take it to recover some of the some of the biofuel or the biochar, then see what is the application for the biofuel and biochar. So in that study, initially our focus is biochar only, but we found that there are a lot of the liquid high resist products. We found what is the component of the liquid product. Oh, we found that the liquid product have very high reducing sugar. And if we have the high reducing sugar, we can convert it into what? Ethanol. So this study we convert two products. Main product is the biochar, and the liquid product we convert it into the bioethanol. So we study what is the thermal behavior of the biochar as a solid fuel or other application. After that, we further study. So what is the suitable applications for the biochar? We try a few applications. First is we can use it as a solid fuel, as a bioabsorbent. They accept some wastewater, and also can be used as the biofertilizer. Biofertilizer can be used directly, then or it can be the house for the what? Some bacteria. Can be housing for some of the bacteria, useful bacteria for your plantation. Because if we just put the fertilizer directly, maybe it will be after the raining day, the what? Your fertilizer will be go away. So the biochar is one of the very good medium to trap your fertilizer. It can be used as a biofertilizer as well, and also the bioabsorbent.
Excuse me, sir. Don't need to dry. It says that wet biomass is not dry.
Yes, we no need to dry. Later I'll show you. Yeah.
So two questions.
Yes.
This microalgae, you can grow that in both fresh water and seawater?
Normally we grow in the fresh water. Fresh water. Now I have the projects. They plan to grow into the sea water because we don't need to use the fresh water. See how can we study the stress behavior, whether it can overcome to live in the sea water or not. See what's the stress behavior. This is what we have to study. Because why? It can counter in the sea water, then it can counter it.
Does it have good yield? So for example, if you have say
highest
good yield.
Highest yield is compared to other type of the fuel.
No, from algae to diesel, yes. But in the water.
Yes, higher in terms of what? Per hectare of the land.
Okay.
Highest that means what? For the Jatropha is around 1,000 kg per hectare. 1,000 to 1,500 palm around 4 to 5,000 higher, so that's why pump is variable. Then this one more than 10,000 per hectare, but they have their own problem. I don't want to tell you now. They have their own problem. Micro area is the highest, I can say, per hectares of the land is highest. Yeah.
Regarding this purification process, once the product of that purification process, can we still consider it as biochar? Because it is actually, even appearance-wise, it looks very different and its properties is also very different, no?
No, what is your question? Your question is?
So biomass we are converting to biochar generally through the pyrolysis process.
Correct.
So instead of pyrolysis, when we use purification at lower temperature, the product that we get, can we still consider it as a biochar?
Yeah. No matter what you want to name it, this is just a name only. So some people name it as a hydrochar. Hydrochar. It's a beside name is a hydrochar. Yeah, whatever that you want to name, this is just the name. Like the torrefaction. If for me, I can say this is a mild pyrolysis process. It's just the name. Then sometimes people tell it the hydrothermal carbonization. Why? Because they focus on the carbonization product. So the concept still the same. So in our lab, we design our own reactor, own process. So no matter what we want to name it, we want to make the process success only. What is the name is what? The company, this equipment is for the hydrothermal carbonization. This equipment is for the wet actually the concept is almost similar. You can modify or whatever. But if you buy directly, without knowing what is the concept and fundamental behind, you cannot modify, cannot play around. Then you cannot get the unexpected product. Sometimes unexpected product is the product that variable, you know. If you just follow the very commercial process, so you know definitely what is the product already. So what is the research, the spirit of the research come from? Nothing. So normally we design our own process. So no matter what I want to name, my reactor I can name it as a gasifier, pyrolysis, same thing. The concept is same thing. I just focus on different product only for me. But you don't tell your lecturer or whatever. This all are same because for them, your professor, your lecturer, need to teach you all. The process is different. Yes, it is different. The equipment and instrument, yes, it is different. Different from different product, different from different process, and different from different final product that you want. It's different. But for me, because I discover whatever the equipment I want to name it. Maybe no any name because my process I modify the process A, B, C, mix together or whatever. We play around with any process. So whatever you want to name it, the solid product, can we name it the biochar, hydrochar, or whatever name that you want to name it. Yeah. So I look back the characteristic, the fundamentals of the product, or what is the characteristic of the product.
Yes, that is different, sir.
Yeah, that's the different. Of course, it's different. Of course, it's different.
Surface area changes, even uniformity changes.
Correct. But how you going to define the biochar? What is the surface area for the biochar? What is the size?
Okay, biochar surface area can be vastly different, but from the same feedstock, when we do through torrefication, the surface area that we get will be very different from what we get through biochar process. No? If we are
Correct.
trying to use it as an adsorbent, I
Correct.
find that very often the properties will be different if we are trying to use as an adsorbent.
Correct. 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 Yeah, you are right because you're focused on the biochar, so you want to get a certain property. You already have the concept. I want to design my process so that I can get the certain characteristic of the biochar property. Yes, you're right because your focus is on the biochar. Then you have to design your process to obtain that property of the biochar or your product, or you can name it any product by your name. Yeah, correct. Yes, correct. We do agree. Yes, correct. You're right.
So, how do we know the exact solid to liquid ratio without trying the wet purification?
Okay, the ratio. For my study, we also study the different ratio. It depends on you. So again, back to that madam question. It depends on what is the process, what is the final product that you want to design. As the ratio, I cannot tell you one ratio. You have to try up the ratio that you want so that you can get your desired final product. Understand? different process, different process, different characteristics, different process, different parameter, different temperature, even the different ratio from the experiment. Experiment, of course, we must have one standard benchmarking study. For example, a certain percentage, this is the percentage, then maybe 10% of the liquid, 20, 30, 40, 50, then see what is the difference. So we are doing a discovery work, research work. Then after that, we found that, oh, this one maybe 30%. We found the product is a very unique product, can be used for maybe application A, B, C, A. Then we further study, further improve the process so that we can get and design to get the product A. Example, for the certain purpose, or maybe as the bioabsorbent, for the maybe for the wastewater, for the industry wastewater, maybe for the semiconductor wastewater, to recover back the heavy metal. Example, then we can design toward that thing. Then you design the process. So during the discovery, for us, our group, we just let it open. We try any process, how to treat the waste so that we can get more value added products. Yeah. Yes.
Even if the energy content of microalgae is high, if we are using palm oil or any other biomass, they consume less time if we are doing the thermochemical process. But definitely microalgae will take much time. But if I want to commercialize this, so I don't think microalgae will be best.
Correct. That is another problem facing by the microalgae. This one I told you. I didn't say the microalgae is a good product, the definite product for the certain things, I just introduce you with the microalgae. As I mentioned just now, microalgae to convert into biofuel facing a certain difficulty as well. Facing the certain difficulty, even though he has the highest, I can say, Green has the highest yield for hectare of the land. Yeah, it's the highest. But the overall yield is very less, and you will get more biomass compared to the bio oil. Even per land area is a lot. Yeah, that's the thing. They are facing the challenges. So these all challenges, we need to find a way to overcome. That's the thing. Yeah. Correct. So that's why people even modify the microalgae, modify so that it can be suitable for certain things. And also, another problem, the contamination will be happen because it deal with the microalgae. It's one type of micro. So the easily get contamination. One contamination, the whole pond cannot be used. That's another challenge that you have to overcome. Then the good thing about the microalgae is what we can say is the net zero process. Why net zero? Because it consumes CO2 to grow. Consume CO2 to grow, you can say not only net zero, you can say negative, negative emission because it consumes the CO2. Yeah, it's very consumed, very consume the CO2. It's one of the things about the microalgae. This one is another study. We have the stream wastewater. Stream wastewater, we use that stream wastewater to counter the microalgae. Because just now, back to your question, whether the algae can be grown in the seawater or not, or whatever. If every time we need to use the fresh water, also consume a lot of the water resources. So we try to use some wastewater, This study I conduct in the Taiwan. So we grow the microalgae using the stream wastewater. Then after that, we found that the water can be treated, by using the microalgae, and at the same time we can correct the microalgae biomass. Yeah, this one is I think kill 3 stones. Kill 3 birds with 1 stone. First, the water can be treated. Then we have the microalgae. Microalgae is one of the absorbent of the CO2. It consumes the CO2 to grow microalgae. So we have the certain percentage of the protein. The protein can be extract out for any other purpose. Then the biomass can be further processed to produce the the bio oil, bio crude oil. That one is bio crude oil. We stop until bio crude oil. The bio crude oil maybe can further process to produce the biofuel. To convert it into the biofuel. Then the biochar we also stop here, but we didn't further process, so we can study what is the properties for the biochar or hydrochar, because we are using the hydrothermal reactors. Yeah, this is another study. We found that the COD can be removed by 92%. 92% if we use the stream wastewater in the cultivations of the microalgae. And then the total phosphorus can be reduced by 93%, then the ammonia can be reduced by 95%. So this all can be one of the nutrients for the microalgae. Yep. Any questions? What is COD is the compound oxidant. Chemical oxidant compound. Is one of the parameters to measure the wastewater. If higher COD, that means they are polluted.
So how this microalgae is removed from that cultivation process?
Because that one, the wastewater have the certain nutrients. The certain nutrient can be one of the food for the microalgae. It consumes. Nutrition. Yeah.
So sir, how it is sieved and removed to get the microalgal biomass?
From cultivation, how you get
That one harvest. We need to go through the harvesting process. That one harvesting, but I didn't show you in details. Harvest. We need to harvest. Harvest.
So you're sieving it or
No, we harvest it, sieve it, correct. Then drying process. Go through the drying process. Yeah, that one. Correct. But you see, when you look at the result, you have found one problem. You see, out of 1 liter, you only can get 6 grams only. There is a thing. There is another. Yes, correct. 6 grams only. Yes.
So we are saying it's a hydrothermal process and we don't need to dry the feeder stock for the purpose.
You mean this one, hydrothermal to biochar?
Yes, but the feeder stock doesn't need to be dried.
Feedstock no need to be dry. This one,
But,
for this process, no need to be dry.
From the image, it's clear that the feeder stock has been dried for.
No. Okay. This one for the illusion purpose only. Okay. I want to clarify here. This one is only the simplified process. Later on, throughout these 3-4 days, I will discuss in detail each of the process. This one is to let you know the overview. Overview. This one is only for the illustration purpose only. We using the half dry microalgae. After harvest, we didn't go through the drying process. Drying process means we are not putting in the oven to dry. Then this one not our microalgae. This one is just the photo. Then we just use the wet biomass, microalgae biomass with the certain percentage of the liquid product. 5%, 10%. Of course, we take our benchmarking. So how to measure the 5%, 10%, 20% of the liquid product? Yeah, with a certain ratio. With a certain ratio. If you want to know more details, you can go to this study. This study will describe in very details the process. Yeah. This one we are not drying. But just now back to that question, because I just explained how to make it to the dry powder, totally dry powders. Yeah. Correct.
We had done this earlier, that's why.
Ah.
Rather for the fish food actually.
Yes. Correct. You know, After this one, the microalgae, the biomass. After we extract the lipid content, the protein content or whatever. This one can be another purpose is can be the animal feed. Animal feed. Animal feed. Yeah.
There is a different kind of industrial uses. If we grow
Many.
algae, then we can go for another kind of perspective also, like
Correct.
not only for bio, but for another industrial.
Can be many other purposes. You see, what you want to focus on. Yes, correct. This is also one of the factors. Yes, correct. Yeah, right. Can be have the many purpose on the microalgae. Yes, yeah, right. True.
But in this case, we have used the oven, but is there any other process on?
No, open dry process is most cost effective.
Exactly.
Most cost effective.
We use two processes like air dry process and oven dry process. Like in aquaculture, we can make it like simply dry it, or another one is going for the
Yeah. Yeah, currently the open dry process is the most cost effective and most easier and direct process for this patient has the sunlight. Of course, provided the patient has the sunlight. Yeah, correct. The open dry process. Most of the industry is still using, for the mass production of the biomass or whatever, they are still using the open dry process. Yes, unless the product you have to control product with a certain percentage, very precise certain percentage of the moisture content. Cannot have you have go through the industrial process. After the open dry process, then you have go through the maybe the oven dry or whatever process to make sure the moisture content is lower to the certain limit. Yeah. So this is one of the studies that I'll cover. Oh yeah, this one focus on biodiesel. This one is the thermochemical process. This one, what we are doing is, you see, like microalgae. We have our microalgae. We culture our microalgae to extract the protein or whatever the leftover. We can go through the thermochemical process. And this one the Jatropha the oil, because from our previous research. We using the Jatropha to extract the oil, right? To extract the oil, and after that the biomass waste. And what we going to do? So we go through the thermochemical process, see what still have some value or not. So similarly, we try the spent coffee ground, go through the thermochemical process, then see what is the applications. This is the biochar that you mentioned, right? This is the process. And these applications. So if in more precise, that one is a wet microalgae. This is a wet microalgae. We are modified using our household microwave for our experiment. For this experiment, household experiment. Why? Because the temperature distributions might be more accurate. Even now, I design another reactor so that we can study the heat map. So whether it's the heat distribution equally or not. Correct. We can see the heat map of the. So like I mentioned, we like to design our own reactors. Now I am still keep designing the reactors. Then this one go through the wet torrefaction process. This one is the wet form, not necessarily in this form. We do calculate how many percent, how many percent, not directly using. Then we calculate how many percent with the certain benchmarkings. Then go through the wet torrefaction process. Then with the nitrogen gas. Okay. One thing is very important. If you want to work on the thermochemical process. Normally, we have using some gas, right? For example, the nitrogen gas or whatever, so that they have no any what oxygen, so that they can avoid the combustion process. If after the combustion, so your biochar or whatever has no value or your product has no value, so you can use the nitrogen, can use the hydrogen. It depends on your final product. What is your final product that you want? So we go through the nitrogen, then we have the solid biochar and liquid hydrolysis products. Then for the biochar, then we study the prospect analysis and ultimate analysis and see what is the composition, the chemical composition of the solid products. Then see the high heating values. Then go through the TGA, see the degradation, thermal degradation curve. Then FTIL and SEM. Look at the what is the potential applications for the solid product. Not necessarily to be used as a solid fuel. Can be other purpose. Then for the liquid product, we found that we have the high total reducing sugar. So with the reducing sugar content, we are able to convert it into the what? Bioethanol. So that's why we further do the fermentation process and to convert it into the bioethanol. Yep. Any question? Any comments? This one is another. This one is study. This study focus on gas product. Focus on gas product. In Malaysia, we have a lot of the palm oil meal effluent. We call it the POME. Palm oil meal effluent is a wastewater from the palm oil meal. So we go through the wet torrefaction process. We use the wet torrefaction process here as a pre-treatment only. Then after that, we use the torrefied POME. Go through that fermentation. We can produce the biogas. Biogas can be produced. And after that, we also do the optimization study. So this is the gas product that we get. So for our group, I think yesterday I told you we focus a lot on the liquid product and also the solid product. Gas product is relatively new for our group. We just started 2-3 years ago. Relatively new. So this is one of the study that we focus on the gas product, biogas or the syngas that we able to produce. We also using other type of the feedstock or raw materials to produce the syngas or even the biogas. But the overall yield is not very high. So that's why for me I prefer to use the biogas as a byproduct. I focus more on the liquid product and also the solid product. Then biogas I feed back to the reactor, so that the reactor don't need to use the electricity. And this is my target. Yeah.
So can this biogas be used as an inert like carrier gas in this manufacturing process instead of using again separate nitrogen?
Can. So after the process it can be used. Yes, can. Yeah, right. So that's why biogas always is my byproduct. So now I want to study how I can utilize that byproduct. Yeah, how to study. So to feedback look here to the burner. If the industry process not if this is go through the burner to burn this. Yeah. Go through the burner. So this one is more on the circular economics. Circular economy. This one I played for the Malaysian National Biomass Action Plans. We have the action plan. Yesterday I told you we have the action plans for 2023 to 2030. How we going to utilize the biomass that available in Malaysia to produce something, the biofuel, bioenergy, and some value-added product, not necessarily energy-related products. So you see, we have a lot of palm oil plantations in Malaysia. So the palm oil plantation, the fresh branch of the palm oil sent to the palm oil mill. Then we have the empty fruit branch over there on your right hand side. This one. We have the empty fruit branch after processing. This is the biomass waste, empty fruit branch, and also the palm kernel. Palm kernel. And this one is the palm trunk and frond. Then we send to the centralized correction centers. Then throughout can distribute and through the different process. It can be used as a biofertilizer, sent to the biofertilizer after processing. Then can be sent to the biomass pellet plant. Biomass pellet plant means what? After processing the biomass, it can be used as solid fuel. Sent to the pellet plant and generate some electricity. Then the semi-treated you can send to the next gen palm meal to produce the paper. The paper. Then can be used as animal feed like you mentioned. Then animal feed, then we have the wastewater treatment and can be treated the waters. Then at the same time, we can have the renewable energy sources. Renewable energy sources for the biogas plant. Then the byproduct can be sent back to the fertilizer. This one you can using solar energy. So this how we going to have the overall life cycles for the palm biomass correction and also the processing. Because if we look at the process in single line, it's not possible. The cost is much more higher. So how we need to make it feasible? Look at the overall. Like this one, overall circular economy. Overall circular economy. You see, we have the palm oil, anti-food branch. Anti-food branch have the polymer, have the fibers. Then you can send to the different process, different branch. And from the different branch, we can have the what? The green energy, for example, the solar energy, the bioelectric energy, or the biogas plant, or the solid biofuel plants. We have it, and some it can be the bio fertilizer to become the compost, and also go through the fermentation process, digester. Then this one can be used, just now I mentioned the format, the palm oil meal effluent can be used as a microalgae cultivations in format, because at the same time can treat the format, palm oil meal effluent. Then this one, the waste can be boiled down the bioplastics or animal feed and go back to overall cycle. See, so this is how we're going to utilize it to make it overall circular. Yeah, circular. Not only the single process we use, but make the overall circular economy. Yeah, this one is I adopted from one of the study. Yeah. Yeah, this trend that we can put on this. Of course, for us as a researcher and a scholar, we must focus either here or either there. But we must have the big vision and mission so that we know what we are doing. So what is the process and what is so every the contribution for every part is also very important. Very important.
Is it commercially successful?
This one is the concept that from our government, our country since 2023, we are working towards in that direction. We want to utilize the biomass waste. Yeah, successful or not successful, we need to wait for another 3 to 5 years. How is the effect?
Can we take a break here for 15 minutes?
Yes. This is the last slide, I think. Okay, last slide. Yes. So, like usual, this one is the world is moving towards the renewable energy to reduce the CO2 by 40% in 2015. So, biomass is one of the potential. The biomass is not the only solution. It's one. Don't take me wrong. Biomass is one of the solutions. Not the only solution. It's one of the solutions. Yep. Yeah. So then our job is how to make the overall process is sustainable and green, so that we can turn this biomass waste into the sustainable energy or any type of value-added product. So with this, I think we take a break for 15 minutes. Yep.